We've all shaken a jar to mix something. Now imagine doing that 60 times per second at forces up to 100 times gravity and applying it to some of the most advanced material in additive manufacturing. Most people in additive manufacturing focus on the printer, the laser, the nozzle, the build chamber, but the material going into that machine matters just as much. And how it's processed before printing can make a significant difference in the final result. Montana Mixers develops what they call VROM technology, vertical resonant oscillatory mix, high-frequency mixing systems originally built in Butte, Montana, that are now drawing serious attention from the AEM materials community. Their systems can handle powders, liquids, and pastes with capabilities that go beyond mixing, including particle milling and coating, all controlled through their browser-based software MixOS. To understand why this technology is relevant for additive manufacturing, I'm about to speak with Dr. Peter Lucon. Montana Mixers has built a strong reputation in industries like pharmaceuticals, energetics, and so on. What brings you to the additive manufacturing space specifically, and what kind of advantages does VROM technology offer compared to conventional mixing and processing methods?
Yeah, so VROM offers some bladeless mixing, so you just have a vessel, moves up and down, like grabbing a jar and shaking it up and down really fast, 60 times a second, up to 100 Gs of acceleration. So it mixes things very quickly and rapidly and doesn't separate things. So you get constant mixing, and it mixes the material throughout, so it sends pressure waves into the mixing vessel, and those pressure waves, as they interact with the particles as they move through or propagate through the vessel, it creates these little mixing zones. So you get better mixing throughout the entire vessel as opposed to tumble blenders or other types of mixers that are out there.
And how do you normally measure this quality difference?
A lot of it is the end-use product where you measure it, but many companies have their own in-process measurements or their tools to know. Some even cosmetics may test the material on their own skin as they're doing to know quality and the pigment or colors, or know that it is mixed homogeneously.
So your lineup covers a range of sizes for AM applications, whether it's lab scale R&D or full-on production. Does the resonant mixing process scale well across those different contexts?
Yes. So we have anything from the benchtop, and this is the pilot scale that we have here. And it scales by matching the power density, so the power per kilowatt, and we can match that throughout the scales. And we can go up to higher production volumes with our larger vessels through automation. Then it's a match continuously called a semi-continuous operation.
We know VROM technology has shown real promise for processing metal powders, particularly for laser powder bed fusion and so on. But are there any other material families that you guys are looking at?
Yeah, so the printable inks as well to make suspensions with their small materials. So they need a homogeneous mix, as well as polymer additive, doing a mixture of the polymers to make an alloy, essentially a polymer alloy, and do that before the extrusion process and have a homogeneous mix and not relying on the extruder to do the mixing for you.
Okay, and if I'm in the industry, but half of what you're saying sounds too complicated for me, do I just go on montanamixers.com and someone from your team an expert will guide me?
Yep, and we have technical staff, sales staff, as well as myself, PhD. So if you go in the info, your queue gets directed to the level of interest that you have. If it's just starting off, just basic info, talk to a salesman. But if you know a lot more about your process, you get tuned in with engineers and process engineers. And then as you scale up and bring it into the more of the process, that's where myself and our control colleagues get involved.
And for someone in the additive manufacturing industry who's curious about resonant mixing but doesn't really know where to start from, which is, common, what does the first step actually look like, in your opinion?
The first step is, what is the application, and give us a call and we can take them through if it is, and can we help them in that. So a lot of times with solid or even suspensions and liquids, if you have a slurry and you want to mix smaller particles and get them suspended, there are certain aspects of this mixer that allow that to happen better than other mixers and much faster. And we could do a lot of things where you may get mixtures with solid-solid with different discrepant densities where other mixers won't work. This mixer will work, and there we can pull a vacuum and we take the sound out of the equation, and now it's all particle to particle. So even though it's just different material densities, gravity acts on them the same, so they all fall the same essentially. So we're able to mix and suspend this mechanical fluidized bed and keep all these different materials mixing and fluidized, and then you don't have to worry about segregation during the mixing process.
So you've been in the company for 2 years now. When we look into the future, how do you imagine Montana mixers in 2028?
Montana Mixer is going to be in a lot of additive manufacturing companies and in their processing and production lines. With academia, learning additive manufacturing took a reset in life, really wanted to focus in on additive. I've always looked at it from growing up and wanted to embrace it. So we started off with polymer and then also grew into metal additive manufacturing in our research group at Montana Tech. And really learned what are the understanding of the process and current cutting edge. And that's really why we wanted to start Montana Mixers, is give the users that experience and actually something that would work for their materials, and the frustrations on getting good mixtures, good processing, or even bad prints that you don't know what it is. And a lot of times it starts with the mixing or the post-processing of materials, as opposed to, we're always concerned on the processing or the printing, but a lot of times maybe it is the materials that we're using, and that's where we're trying to address.
That's great. Well, Peter, thanks so much. Really appreciate your time.
Thank you.
Thank you. What started as a simple idea, shaking a jar, has evolved into precision processing technology that could change how advanced materials for additive manufacturing are developed and produced. If you want to see more stories like this, feel free to check 3D Natives.